mirrored circuit of figure 8.2 with two transistors having equal channel lengths, but with Q2 having a width 5 times that of Q1. If I reference is equal to 20 microampere and the transistors are operating at an overdrive voltage of 0.2 voltage, what IO results, and what is the minimum allowable value of V0 for proper operation of the current source? If Vt is equal to 0.5 voltage, at what value V0 will the nominal value of I0 be obtained? If V0 increased by 1 voltage, what is the corresponding increase in I0? Let Va is equal to 20 voltage. Okay, so first they are asking for the current I0 right here. I reference is provided to be 20 microampere, but usually current mirror mean this one and this one is equal, but it's only happen if it's matched. Matched means the length and width should be equal, but here the length is equal but the width is 5 times greater in the second one, so this is not going to be equal. We have to calculate the value. To calculate the value, we can put an equation, and we know that the width of the first one, if we say width of the first one as W1, that is equivalent to 5 times, or we can say W2 for the width of the second one, that is equal to 5 times width of the first one, if we consider W1 as the width of the first one. And if we consider the length of this one, L1 and L2 are equal. Whatever the length here is the same length here as well, so that is equal. Only these two are different. So to find the current, I0 current, we can create the equation, that is I0 is equal to I reference times W over L2, and then that one divided by W over L1. Okay, and then if you write this I reference times, this is W1 over L1 over W2 over L2 and W1 over L1. And here we can try to replace everything in order to cancel each other. So okay, we know that we need to have it in the same, like if it W1, both of them has to be W1, so we can cancel the terms. So instead of W2, I can replace that one with 5 W1. So this is going to be I reference times 5 W1 divided by, instead of L2, I can replace that one with L1 because both of them are equal. So I put the L1 here, and the denominator I keep it as it is, W1 over L1. And from here you can see W1 cancels, L1 cancels, only the 5 is remaining. So it means whatever the reference current is, if you multiply that one by 5 times, that's gonna be the I0 current. So we already know the reference current that's provided in the question, that's to be 20 microampere. So we just have to multiply that one with that one 5 times, because from the equation we derived, I0 is equal to 5 times I reference, so which is equivalent to 5 times 20 microampere, which gives us 100 microampere, and that is our I0 current. Okay, so now we have I0 current. What else required? Let's look at the question. So they ask us what the I0 results and what is the minimum allowable value of V0 for proper operation of the current source. Okay, we have to find out the V0 minimum value. V0 minimum is basically the drain source voltage at the second one, V0. Okay, drain source voltage is the second one, and that is minimum when it's equal to overdrive voltage. and the overdrive voltage is provided in the question to be 0.2 voltage. So we know that the whole thing is equal to, like, V0 minimum is basically 0.2 voltage. Okay. So that is one question. What is the minimum allowable V0 for proper operation of the current source? And the next one is asking, if Vt is equal to 0.5 voltage, at what value of V0 will the nominal value of I0 be obtained? What value of V0, the nominal value of I0 will be obtained? Okay, so to find this one out, here we need to find the gate to source voltage. Let's use a different color. So we know that V overdrive can be written as VGS minus VT. And here we are trying to find VGS. We already know the VO. We just calculated that to be 0.2. And then V threshold is provided in the question, that is 0.5 voltage. So from this one we can calculate the VGS. If we rearrange this equation, VGS is going to be V0 plus VT. V0 is 0.2 plus VT is 0.5, and that's going to give us VGS to be 0.7 voltage. Okay, and the drain current in the linear region, can be expressed like this. Let's mention here as well. The drain current in linear region is I is equal to I reference times the equation we already did before, that is W over L in the second one divided by W over L in the first one. That one multiplied by another term when it's linear, that is 1 plus V0 minus VGS divided by VA2. Okay. So what we can do here is we can keep this one in the one side and bring all the other things to other side, because here we are trying to solve for this V0. That is the question we are trying to solve. Here the question is, if Vt is equal to 0.5 volt, at what value of V0 will the terminal value of I0 be obtained? That's the one we are trying to find out. So we have to keep it in this side, and if we flip all around, then this is going to be I over I reference, and this whole thing will be in the denominator. That's going to be W over L2 divided by W over L1, and in the other side of the equation we will just have this 1 plus V0 minus VGS over VA2. Okay, I'm looking at the VA value, that's also provided over here, 20 voltage. Okay, so we can substitute that one as well. VGS we already calculated here, 0.7 voltage. Do we have all the values? We have the VA, we have the VGS. This one is basically I is okay, let me double check. Yeah, let's substitute all the values and see what we get. So and also for the nominal value here, it's mentioned if Vt is equal to 0.5 voltage, at what value of V0 will be the nominal value of I0 be obtained. So nominal, when they say nominal, there's a condition we have to consider, that this ratio will be equal to 1, I over I reference W over L2 over W over L1. This ratio will be equal to 1. The condition for nominal value of current is condition for nominal value value of current is this one. So if this is this, then now this one become easier, because now instead of this whole term we can just substitute 1 and solve for it. So substitute this in the equation, substitute in the equation. So this one become 1 plus V0 minus VGS over VA2, 1 plus V0 1 plus V0 minus VGS divided by VA2, the whole thing becomes 1. So if I move this one to the other side, that's going to be a negative 1, so that's going to make this one 0. So V0 minus VGS over VA2 is going to be equal to 0, and VA2 is 20, and if you bring the 20 to the other side, that's going to be 0 as well. So finally VO becomes equal to VGS, so which means this is equal to the VGS value we calculated over here, that is 0.7 voltage. So this is also 0.7 voltage. So the answer is VA should be 0.7 voltage to obtain the nominal value of current. Okay, if Vt is equal to 0.5 voltage, at what value of V0 will the nominal value of I0 be obtained? That is when V0 is 0.7 voltage. Now let's look at the next question. If V0 increased by 1 voltage, what is the corresponding increase in I0? Let Va is equal to 20 voltage. Okay. Let me read the question again. If V0 increases by 1 voltage, what is the corresponding increase in I0? Okay. So here we are increasing the V0 by 1 voltage. So what will that do to the current I0? Let's look at that. Now in order to do that, we have to find out the output resistance, that is RO, or you can say RO2 as well, which is equal to VA divided by ID2. We are looking at the output resistance right here. That is divided by, that is VO divided by VA divided by ID2, and the VA is given in the question, that is 20. ID2 is, we calculated over here initially. The current in this side is 20 microampere, and this is the width of this one is 5 times larger as it mentioned in the question. So we calculate this one to be 100 microampere. Okay. So this one is ID2 is 100 microampere. Put that one over here and solve for the R0, which becomes 200 times 10 to the power of 3, which is 200 kilo ohm resistance. Okay, Now we have this, and this one is helpful because there's another equation for the R naught, which is equal to delta V naught over delta I naught. So from this one we can solve for the current. So delta I naught is basically delta ID, which is equal to delta V naught. Like, we are looking at if we change one voltage, what will happen to the current. So put 1 voltage, and the resistance always remain the same, that is 200 kilo ohm, and that will give the results of 5 microampere. So the drain current will change by 5 microampere when you increase the voltage by 1. That is what it's proving. So we can mention here, thus the change in drain current is delta ID is equal to 5 microampere. And that's it. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.